Welcome back. I'm excited to show you what I've done for the last 3 months. The robot's finally starting to move, which is super cool. Pretty soon the software will be generating itself, which will be awesome. So let's dig in with a little clip about the mechanical changes that I've made in the last 3 months. Some of the mechanical changes that have happened since last time. Nephele's hips were printed in ABS with tiny gears with tiny teeth. They were flimsy, they were weak, they were not good enough. I designed new gears and a new gearbox that's way stronger. The gears are printed out of nylon. They have teeth that are more than twice as big. The new hips are solid. I'm really excited that I can design and machine a circuit board with my router within a matter of hours. I love that I get back to soldering and electrical components. With desktop manufacturing and microcontrollers becoming ubiquitous, it's brought back some of the childhood joy that I used to have playing with circuits in the basement. I put together a little sequence for you about some of the recent changes to Nephele's circuitry. The instrument tower with the motor controllers that I built in the previous video had some issues with it. The little wires stuck into the Arduino weren't making a very good connection, especially with what I think was the ground, because the motors would have almost no power, especially if there were 2 or 3 motors connected. I had the 12-volt power supply hooked up to V-in on the Arduino, which ended up burning out the Arduino and all the Hall sensors, which sucked. I created a Shield circuit board to go on the Arduino Mega to formalize the grounding and the 5 volts and the 12 volts. I replaced the instrument cluster tower with a ribcage kind of design while consolidating the motor driver boards to just a single type of motor driver. In the end, I'm really happy with the way the design came out. I made a couple upgrades to my equipment since last time. I got this very quiet air compressor that I can run in the basement and blow the chips off of whatever I'm working on my router. It has the unusual side effect of making my son fall asleep really quickly.
No, don't!
I got a 3D touch sensor for my printer. Finally, I have accurate Z-axis homing. I was going to do a 25-part lecture series about Nephele's amazing software, and I'm sure that most of you would have been thrilled for that. But there's definitely some of you that probably wouldn't even make it through the first 5 parts. And you guys ruined it for everyone else. So instead of going through all the details of all the little technical aspects of the software, I'm just going to show you what it looks like to design something in the program I built to generate Nephele's software, so you can get a feel for roughly the angle I'm approaching with it. I think it's really cool, but I'm kind of a nerd, so your mileage may vary. This software allows me to design the logic that runs between the sensors and the motor controllers. Using different mathematical nodes, I can take the values from the sensors and manipulate them and compare them and multiply and divide them and do other things, ultimately coming up with some kind of reasonable output. What you're seeing on the screen is me designing a set of nodes that will report a 1 when the robot is steady and stable and upright, and otherwise will report a 0. This 1 and 0 can then be fed into other things which might manually adjust constants for like the gyroscope's offset, for example, to ensure that over long periods of time the gyroscope doesn't get out of sync with the proper up and down orientation of the robot. That's just one example of how this might work. Also, there are several different ways that these nodes could have been arranged, but the way that I set them up here works just fine. It ends up having 3 different checks. Is the current value very close to 0? Is the average of the value over the last half second very close to 0? And is a weighted integral of that value over the last second or so very close to 0? If all 3 things are true, then the series of nodes indicates that the robot is stable, and it turns the green light on. Thank you for following along with my project. It's really fun to get to share it with you guys. I'm Josh Whitman with Whitman Technological. I love science, and I hope you do too. I think that's it. Short and sweet, right?